and chose not to come in and do quizzes. All right, so this is old stuff. So it's just reminders of stuff you should already know. Then we'll get into some new stuff, which you have a quiz on Tuesday, next Tuesday. It is one of the more difficult topics. I am cutting out the most difficult thing. So if you read the book problems, like the examples, and try to figure out what they are doing, I am not doing it that way. It is a very complex lesson. And to do the entire process, first of all, would just take a long time. No eating, please. I had a big blowout today, so I don't want you to eat today. I'm going to show you a way that I feel like will cover. Really, I mean, I've never seen a problem other than IXL where this doesn't work. IXLs, it doesn't work on some of the problems for sure. So just know when if you practice IXLs, you're going to get some that it doesn't work perfectly on. But just make sure you focus on the ones where it does. Because I'm taking the quiz again from IXLs, maybe possibly all the questions again, except the IXLs aren't perfect, but there will be some in an IXL that are perfect, but there'll be a lot that aren't perfect. Just know you're gonna have to weed through those. All right, so you gotta know number one. Like that is the absolute. Oh man, yeah, that's it. They sent a message down for you, but you weren't here, so I seen that. You're supposed to go somewhere, but I don't even know where now. Yeah, I had your name on it. It said immediately, but I don't even know where it goes. Just go ahead and see. You gotta know this format. You've got to be able to pick the pieces out of that format. Sometimes you'll graph from that format. Sometimes from a graph, you will create an equation in that format. You've got to know this. Again, this is algebra. This is not geometry. They expect you to know this in this class. So I can't spend tons of time on it. So with that in mind, that is what format? What's that called? Well, that's the all variable version. It is what though? Slope, intercept form. It literally says slope and intercept right there. That's why it's called that, is because in that formula, they give you the slope and they give you the y-intercept. So, I'll just start with Joseph. What is the slope in that formula? Y equals 2x subtract 3. Not the x. So make sure you understand that is 2 times x. It's two separate things. They can't both be the slope. So what's the slope? Always just the number in front of the x. Or the m is just the slope if there's no numbers. So there's our slope. Next, Trinity, what is the y-intercept then? Only one thing left. What, 3? -3. I thought you said it, but I wasn't. You were unsure of yourself, I think. You got to be able to do that. That's not. I mean, first of all, you had that at least twice in other math classes where you had to do slope and y-intercept, if not more than that. We use that for a whole lot of stuff. We'll use it today a little bit. More so, we'll use the slope formula. What's the formula for slope? There's 2 of them. So there's one with a whole bunch of y's and x's, y2 subtract y1 over x. So that's on your formula sheet. You don't really have to memorize it, just know it's on your formula sheet. What's the one that's not on your formula sheet that was like probably the first one you first started graphing? Well, that's the whole equation of line. That's this. That's not slope. Slope is that one, but there's a formula for just that too. Elijah. So we're going to do this today. So this is another one you have to memorize. When they say formula for slope, this needs to be an automatic. Shouldn't have to think about it. Rise over run. Formula for slope, rise over run. The other formula is on your reference sheet. You don't really have to worry about memorizing that. All right. This format, I'm just going to kind of do it quickly. We don't use it as much as I thought we were. This is point slope form. Y subtract y1 equals m times x subtract x1. So if it's called point slope form, what did we say they give us in that equation? A point in the slope, right? So we still have the slope, It's not the number right in front of the x, like, which in that case would be a 1. And there could be a number also in front of the x in that format. There could be a 2 here and a 4 out there. The slope, though, is just that. And typically, I don't think there will be a number in front of the x, but just so you know. Oh, actually, no, I'll take that back. There can't be a number in front of the x. It'll always just be x. So you won't ever have to put it. So the number outside the parentheses, still closest to x, you can say is the slope. It's right there in the. So how do we get the point? What do we say the point comes from? Trevor. Because in this equation, there's also a point that's on that line. Look at the values over here in the formula. What part of that might be a point? What part kind of stands out as being different? Yeah, the ones with the one, right? That's where you get the point from. The point that's on the line. That y1, x1. So we said it's a little tricky because you got to kind of match up the formula, which is, that's the formula. It says y subtract. Well, if it matches the equation, which it does right there, that is also y subtract, then that means the y1 is what value? Actually, Elijah did answer that. Shamarian, so what's my y1? What is this value right here in this equation? So it's not -2. That's why I put the boxes around it, right? This is part of the formula. So I know it's tricky because it did the number in front of it's always glues to it. This is why it's tricky. You just have to understand that is duplicated. So I'm kind of, if I cover up that and I want y1, it's just 2 in this case. So again, that's a little tricky. Just gonna have to kind of memorize. So that's, I guess I'll write it. So the point is 2 for the y. Now here for the x's, it's not duplicated, right? Over there in the formula, I have y, or I'm sorry, x subtract. In the equation, I have x plus. That's when we have to make it negative. Plus is actually a -1, and I'll show you why. Because if x is -1, I plug it in here, right? So let's say now I'm going backwards, and I was going to create or take these and put them into the formula. I would have x subtract -1. Well, didn't we say that becomes x plus 1? Subtracting a negative becomes addition. So if you need to plug them back in and just make sure it gets you back to the original, that's not a bad idea. We don't use that as much as I thought, but I'm still, IXL does. So you'll see that in IXL. And you got to kind of understand it enough to get through those so you can get to the ones that are more like our quiz. All right, last one then. So again, this first piece you have to know. Like now you should. The next piece you need to get to the stage where you know you've done it before, not anything new. Visually. Or if you have an equation even, I guess, too. Oh, Delaney's up. Easy question for her. What is the y-intercept? Either what's it mean or just tell me the number, whatever you know. Yeah, it is where the line that we graph, or that's already graphed, if they give us a graph with a line, it's just where that line hits the y-axis. And again, don't get them confused. The y-axis is not the same thing as the y-intercept. That's the y-axis, a whole number line that goes up and down. The y-intercept is one point where our line connects with or meets or intercepts the y-axis. So -1. So if I know the formula, slope-intercept formula is this, I know that's the y-axis, right? The b. I can make part of that formula. So when I have you creating equations, which we're getting to, you should always, if it's from a graph, be able to give me that. The slope, you got to kind of know how to figure out, but you're just taking a number off the graph to give me the last piece. And that gets you points. like I said, it's not always about getting every single problem 100% correct to make, C's and B's. And A's, you kind of got to be pretty good, but you can get C's and B's with a lot of partial credit. That's a lot of partial credit. You did have really half the problem. I'd give you credit for half the problem, depending on how tough the lesson was for you. Now, though, for slope. So here's where we use that slope formula, rise over run. Yeah, I can still use this. So if I know slope is rise over run, again, that's formula for slope. I just need to figure out, well, what's my rise and my run as I go, oh, what's the slope of that line, positive or negative, blue line? Everybody should know that. Negative, if I am Ant-Man, that's Ant-Man. Oh, that's a horrible Ant-Man. Marker's not on a skinny mode. If that's Ant-Man, if I am walking down as I go left to right, we said that is always negative slope. Always, 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 no exception. So if I just know that slope is negative, I don't really have to worry about when I go to figure it out. Oh, well, is like moving to the right a positive number, or is it a negative, or is moving up or down? Is that positive? I don't really, none of that matters. I just know the slope has to be negative. So out in front over here where I'm going to write the slope, I just know that's negative. Just based on looking at the line. That'll save you from making math. Or at the very least, if you do it the correct math way and you try to figure out which values are positive and negative, make sure you understand your final answer better be negative. So now I just say, okay, from any one of these points, I can use two points and find the slope. Why would I not want to use this point? Because technically the slope's the same. I can pick any point on the line, technically. Why is this not a good point to choose here? Oh, boy, super easy. Melinda, why is that not a good point? Green one. Now, how do I know if I'm going to do rise or run and I'm trying to get from a point to, how do I know where I'm going? I don't know what number that is in between the 1 and the 2. So that's why I chose all those red dots. Again, that's -2 on the X. That's 0. That's +2. That's +4. Like I know what those numbers are. That's how you would always want to do it. And there might not always be a bunch of them. There might only be 2 sometimes. So you just got to make sure you look very closely and pick the correct 2. So now from there, we just count. I can choose any of those points I want, any 2. I could choose 2 that are close together. I like choosing them a little farther together. So I'm going to go, I'm going to erase that because I like going right. I always like going right first. My process eliminates mistakes if I always go right first. So my run, I always go right. Even when I'm graphing it myself, I always go right. So I'm going to go 1, 2, 3, 4, and I get to that spot, and I want to be directly above because I'm going to go straight down now to the other point. Actually, let's go 6. 2 more. Get to that point all the way at the end. And now I go down 1, 2, 3. So again, the distances are 6 and 3. Any 3. If I were doing it the perfect math way, I would have to know going right is positive, and when you graph lines, you will have to know this. Going right is positive, so that's +6 over. Going down would be what? Oh, hopefully you know this, but this has been a little confusing. Left and right is your run. Like, think about what rise would mean. Rise would mean up, right? So rise is the up and down. If you're ever getting confused, think through it. What would make sense for the rise number or the run? Like running, I don't go up or down. I just go straight left and like staying level. I'm not going up or down. I'm running, flat. So rise would be the up or down. So if rise is up or down, what would 3 be? Positive or negative? Going down 3. Yeah, going down, kind of like if we walk down, it's a negative slope. Going straight down is definitely going to be a negative number. So that's my slope. Oh, that is so wrong. Nobody wants to correct me. Where does run go? Top or bottom? Yeah, totally messed up. Run is on the bottom. I should have made you come up with that. Should have made that something I asked about. I haven't done that in positive 6, negative 3. Rise is on top. Rise over run. So now here's the last piece that you gotta know. What is that number real? What's a simplified version of 3/6? Yeah, 1/2, right? So your calculator does it for you. I'm not gonna spend a lot of time on it, but that is negative 1/2. That's what you would see on a multiple choice test. That's what will make your graphing a lot easier. The smaller numbers you can use, as long as it's the same fraction, the easier your graphing will be. Who we got? Oh, thank you. So we'll get into more of that. We're gonna use a little bit of that today. Eventually, we'll get to where we're graphing lines and stuff, but today we're just, well, actually, I guess technically today we are graphing it. We do it a different way. Real quickly, I'm gonna show you a couple of shortcuts that may or may not work. I doubt the EOCs and stuff are this easy anymore. I think at one point they might have been. If I want to know if those two lines are parallel, we learned what? What's true about parallel lines? Same slope. So we said, okay, solve for the slope, solve for the slope, the same number, they're parallel. That's the only way you can know 100% you're correct is to do that. If you forget how to do that, there's a concept that might be enough on some kind of an easier test. What's true about parallel lines? They never meet, so can they ever even be getting closer together? Because if they're getting closer together, then at some point they're going to meet, right? So if they are parallel, they will be the same distance apart for the entire line. So just see if they're the same distance apart. Look at one far side, and you don't even technically, we measure distance perpendicular, but that doesn't really matter as long as you're doing it in the same direction. So I go up 3. So if I go from here on the far right, I go up 3, maybe a little bit more than 3 on the far right. So now come way over here. Find a point where you go right through lines. I could do here. I'd prefer to go all the way as far as I can. So that's kind of a little bit below the corner. So I got to remember that. Well, 1, 2, 3, and then a little bit above it. So yeah, that seems like they are the exact same distance apart on that. If they're the exact same distance apart, as far as I can tell visually, pretty good chance they're paired. So again, I don't know that that'll help you anymore these days, but when I did 1A a long time ago, I used to do stuff like that, but they kind of changed tests over time to not be quite as easy. Really quickly, if we graph 2 lines, that's actually not it. Let's make it correct numbers. So let's say we graph 2 lines, or we just get equations like that. What does the graph of x equals a number look like? What I said you had to memorize. Oh, come on. X equals a number is straight up and down. You gotta memorize that for reflection. Hopefully you know it, you're just not answering. Not, then you better learn. So if I graph those 2 lines, x equals a number is straight up and down, y equals a number is horizontal. I cannot test the slopes out with those lines to see if they're perpendicular. Because what's the test to see if 2 lines are perpendicular? Parallel the same slope, but what's perpendicular? Multiply them and you should get what? I can't get -1 because first of all, you can't even solve for the slope of a vertical line. It's undefined. You get an error in your calculator. This slope is what? The blue line. Anybody know what that slope is? What's up? 0. What's that? So the slope of a horizontal line is 0. So again, if I multiply 0 times something, I'm gonna get 0. I'm never gonna get -1. You just have to memorize vertical and horizontal or perpendicular. Or more specifically, this would be what the question would be like. Are those lines parallel, perpendicular, or neither? And you have to then graph them and then know, okay, yeah, if they're horizontal and vertical, then they're perpendicular. So again, that kind of all goes together. I didn't really do anything with that lesson. The only stuff I would have probably done for that lesson we've kind of already done. Just understand if it says something about proving lines parallel and it looks similar to what we did when we saw like that quiz, basically. You're just doing the same thing. Just assume they are parallel and just solve for x. That's all they're saying. And then the actual proofs, I'm not going to worry about. I go fast because now we're to the stuff. But again, you'll be able to catch up by the time. Just go fast. Oh, that is it. All right. So again, I'm not going to keep that on the screen. Just remember, slope is rise over run. Just remember, I'm going to use it, but I want to stay zoomed in on what we're going to do. Slope is rise over run. Just remember that. All right. So here's the way the quiz. This is the toughest thing you'll get on the quiz next Tuesday. They ask in this chapter. Oh, you're on page 209. So turn to page 209. Oh, I did all the first. So they are asking in this lesson, this is the big topic. What is the distance either between a point and a line? So here we just have a point and a line. Or some of the questions are, what's the distance between two parallel lines? So they give you two lines of them. This is a very complex topic. If we were truly trying to learn it, the algebraic and go through and do all the algebra steps. Probably something you did. I'm pretty sure you did this in algebra. Earbuds out, please. I don't want them seeing any earbuds. So especially when it's got long wires hanging all the way down your body, going way down. So no earbuds. Take it out. I'm telling you, they are walking up and down the halls all week for whatever reason. They haven't really come into me, but I've seen them coming out of teachers. I've seen them in the halls. Really just Mr. Yates. I don't know what's going on. I might just be from the visit last week and they're just checking to make sure teachers are doing what they're supposed to be doing now after they've been told to do new stuff. I'm supposed to talk to them. I was supposed to do it yesterday, but they canceled it, so I'll probably do it next week. But so hopefully I'll still be here. So we did this before. It's actually on your last quiz. And we said a long time ago, what is important about measuring distance when it's between objects? Lines, parts of figures. I said it once or twice, not a lot. You may remember what was important about measuring distance. Get it out. Look at the picture on page 209. They drew a bunch of dashed lines. Right, do you see what the one I'm talking about? They didn't have points in it, but they did something like this. But then they drew one like this. What are they telling us in that picture? Where'd I end up? Marlon, any idea, Marlon? Well, why is that one line solid with that thing? You don't know. We don't have any help today. Why are they making that one solid? Veronica. I used to have a guy that said that all the time. And he spoke not perfect, but he spoke. He would write down his quizzes. Why don't you? All right, Christina wants answers. Talk to her.
The right.
So they're telling us it's a right angle. That's the main thing, right? They put that right angle symbol for a reason. And they made that line solid, if you'll notice. It's also not dashed. So what's the lesson? I mean, that's the lesson right there, really. What are they telling us? It's about distance. That's actually that's even more of what they're telling us. That is the shortest line you can draw between that point and that line. There is no shorter line than a perpendicular line. Because of that, that's how we measure distance. We have to draw a line perpendicular and use whatever this point is where it hits, and that point, and again, I just guessed that we're up to B. So that's the point. That's the way you do distance. No exceptions to that. You have to go perpendicular from the point to the line. Yes. Nobody else would play. All right. So we did this before. We drew from a point to a line. We drew a perpendicular line. It was on your last quiz. I don't know how you did on it, but the good news is if you didn't do it on it, you're practicing for that retake right now. I think there was actually 3 problems on that page, but this is one of them. The other 2 are the lines parallel, perpendicular, or medial. So what would our process be? Where'd I end up? Damon, what would our process be? If I want to draw a perpendicular line from here to that line, what would I need first? Kind of did this on your execution. What is perpendicular parallel? What's that about? What's the word? About slope, right? So I'm going to need some slopes. I have no idea yet what the slope is going to be from that point to that line, but what can I figure out? Well, I could do the whole equation, but for slope, I can figure the slope out of the line I have. Like if I have points on a line, if I have a line, I can figure out the slope. So I want you guys to figure out the slope of this line. I'm going to help you a little bit. I'm going to tell you what those coordinates are, so you don't have to try to count them. So this is -3, 0. There's actually a way to do it with rise and run, which is the way I'm going to do it. It's much faster, in my opinion. This is 3, -4. 3, -4. So go ahead. There's the formulas on your reference sheet. Y2 subtract Y1 divided by X2 subtract X1. Go ahead. I'll let you. Actually, while you're doing that, I'll do one more attendance for 3rd period. If you want to do it the rise and the run method, that's fine. If you know what I'm talking about when I say that, that's the way I'm going to do it. Either way, you should get the same answers, though. What? Oh, don't tell me I didn't save it. Son of a gun. That's disappointing. That's funny. I had to come in. Well, hopefully I remember who was here. Young Christian Johnson. Oh, she wasn't here today. Ah. So I'll give you another minute and then I'll just kind of get started. Hopefully you at least have the process down, even if you don't quite finish all the math. She showed up late. She was not here. She was not here. He was not here. She was not here. Oh, shoot. Yup. Did you do the slope? See it real quick. Just make sure you. So D is the five. I'll let you go ahead and go, but just remember that. Make sure you write. That's why I say write the formula down on your paper, then put the numbers in. Well, just tell me what you got. Anything else besides that? Look at the way the line is slanted. We'll look at the way the line is slanted. Would have to be true about the sign of it. So negative, good. The which number is negative doesn't matter. Depends on which way you did it, but yeah, it's got to be negative, right? Just remember, always think about that. Well, I know that's got to have a negative slope. But yeah, those are the correct numbers. Good. And you do have to simplify it to what you said as the second one. All right, so again, if you think about these things ahead of time, instead of just plugging numbers in or trying to do formula stuff, it'll save you a lot of mistakes. What is the sign of that slope? Before I even worry about numbers. Gotta be negative, right? If I'm Ant-Man and I start over here, I'm walking down as I go to the right. And we said that is a negative slope. So I know my slope has got to be negative. So I know my slope's going to be negative. So I just need to remember that at the end. Hey, the numbers never change. The numbers are the numbers because we're counting. Direction doesn't change what the number is. It just changes the sign. So with that in mind, I'm going to do it, like I said, the rise and runway. I'm not going to do X1. You should get the same thing. If you're not, then you just need to practice. So I'm going to go from this point. I could choose any points on there. I could have chosen that one, could have chosen that one. I'm just going to choose the two they give me because I know those are the correct numbers because they told me the numbers. So I go, all right, well, that's 1, 2, 3, 4, 5, and then one more 6. Going to the right is positive. So you do need to know that for when you create the graph, but you don't really have to know it for coming up with the slope if you just understand that's got to be negative. Now I go down 1, 2, 3, 4. So down for my rise. Thank you, because I just realized when I said down for my rise, I made that same mistake last class, and I corrected. I was gonna make you guys correct it, but you already did. Look at Nevaeh paying attention. He's like, Mr. Gill's not always very good, so I better pay attention to what he does. So that is the run. So you put it on top, you made the same mistake I made. Rise over run. Run is to the right in this case. Rise is down. Down would imply negative. I'm going up for my rise, it's positive. Going down, it's negative. And I knew that I needed to get a negative number anyway because of the way the line is tilted. So what's my slope? Yeah, it's really more likely that you're going to either see 2 over 3 or you're going to want to use 2 over 3 because that means you have smaller numbers to count, which is just going to be a little bit easier. Especially if the points are way, way far apart, then that could make it a little tough to use those points. Okay. All right, so that is my slope of the black line. I, though, need to create a line that is perpendicular to that one. What do I need to do? So my line is not going to have that slope because it's going to be perpendicular. Well, this is your X. I'm actually on you, so that'll work. We said that you create a perpendicular slope by flipping and flipping, remember? So if this is negative, overall negative, then I need to make my perpendicular line positive. And I flip, so that's one flip, flipping the sign. My other flip is to flip the fraction. So this was actually what you did for your exit ticket, basically. Now that is the slope of the line I'm going to create, perpendicular to the other line. I know it needs to go through this point right here, right? Because they tell me that the problem. You want to know the distance between that point and that line, which means we need a perpendicular line to do that. So I just count. I just use my rise and run again. My run, and I'm going to use the actual numbers, so we'll cover the other part in a second. 1, 2 is my run, right? The bottom number. Oh, up a little bit. 1, 2, 3 is my rise. And that's correct. That's in the right spot. I could draw a line through it, but I'm going to tell you, I don't like that point at all. I don't like where I put it. It's right, but why wouldn't I like that? I already answered. You know why I don't like that point? You know me really well. You know why I don't like it. What am I trying to do? So what? Did I go toward the other line? I don't like not going toward the other line because it makes it a little more difficult. Because if I act like you see where I drew it, that's not actually right on it, right? It's a little below. So if I connect those, I may not hit the line where I want to hit the line. Flip the signs. We said you can always reverse the directions or flip the directions of it. I'm going to go instead of right 2, left 2. And then I'm going to go down 3 instead of up 3. And if you'll notice, I land exactly on a point on that. That's the point you use along with this point. What is that? 2, 1, 0, -2. Now I can just do the distance formula. So you label it x1, x2. I'm sorry, x1, y1, x2, y2. Plug them into the distance formula. We could also create a right triangle and say, well, if I create a right triangle, there's my right triangle. And then solve for the hypotenuse, and that's also the distance. That's way faster. A lot of you packed up. Remember, this is your quiz question for Tuesday, so I doubt you're. Oh, you also packed up, and this is the IXLs you need to know how to do. So none of you are going to write these down. Those 2 IXLs are the ones that I'm pulling questions from.
Oh my gosh, you just skipped the next song.
Don't forget to take your quizzes if you missed it. Lunchtime or after school, and it's done.
Tuesday, guys.
Yeah, that deadline is talking about. I haven't even figured it out.
Oh.
That's all. Oh. Is that a calculator on here? That's a calculator, right?
Yeah.
It's a battery pack.